So in this video, I will be showing you 3 more examples, example 4, 5, and 6. Here is one more example, example 4, in which the problem is to divide x to the power of 3 minus a to the power of 3 divided by x minus a. So as we can see, the form of the dividend is already similar to the form of the divisor, so there's no need to rewrite anything. We just go straight and apply the formula that we have, that we're using. Applying the formula, yeah, like I said, it's the same. So sorry, we're going to go apply the formula now. So here's the formula. We're going to start off with a as usual. Here's a to the power of 0, and the first term. On this first term, the x exponent is 1 less than the exponent of the dividend. So x to the power of 2, a is going up by 1 the next term. The exponent of a is going up by 1 in the next term. And the exponent of x is going down. And then the next term, exponent of x is going up by 1 to 2. And the exponent of x is going down to 0. That's how we know we are done, because the exponent of x has become 0. So simple enough. This one has only this division here has only 3 terms. Actually, this is called the difference of cubes. This is difference of cubes divided by x minus a. You will find this just these 3 terms that are there. Now the next job is to just do a to the power of 0 times, which is 1, times s squared, and then we get s squared down here, and then a to the power of 1, which is just a, times x to the power of 1, which is just ax, and then x squared times 1, which is just a squared times 1, will just be a squared. There you have it. You have 1 times s squared is s squared, a times x is ax, and x squared times 1 is, a squared times 1, excuse me, is a squared. And that is pretty much what it is. Now we're going to go to another example in the next screen. Here is example 5. Now remember, always the first step is to try to match the form of the expression, and the dividend by the form of the expression at the divisor. So the form apparently don't look the same now, but we can actually, we have a clue here that this 3x should be somewhere here with 3x to the power of 3. And if you do the math, 3x, sorry, that is not working. So 3x, if you do 3x to the power of 3, what you're doing is you're doing 3x times another 3x times another 3x, so which is like you're doing 3 times 3 is 9, times another 3 is 27. So that's the 27. And then you have x times x times x, that is the s cubed. So really, if you do 3x to the power of 3, you will get that. So it's just not obvious, but actually the form is the same. The form is the same. The same way, the 8, we can use 2 to the power of 3 to get 8. Like you do 2 times 2 times 2, you will get, which is actually 2 to the power of 3. So you will get 8. So that this here is the same form over there if we use 2 to the power of 3. So the next screen will show you these have been rewritten so that the form of the dividend is matching the form of the divisor. So there you have it. This is what I was explaining in the previous screen, that we have sort of matched the forms so that they look alike. They're just basically the same. So now this is our a. Our a is 2 now. So I'm going to write that somewhere. So our a is 2. And our x is now not just x, it's now 3x. So bear that in mind when we substitute into the formula. When we substitute into the formula, our a is 2, our a is 2, and our x is 3x, not just x, okay? So now, this is our a to the power of 0, our new x to the power of 2, 1 less than the exponent of the dividend. Our a, which is 2 to the power of 1, and our x, exponent going down by 1. Our a, which is 2, exponent of 2, and our x, which is 3x, now exponent of 0. Then we know we are done when we have x to the power of 0 as the last. So we're going to be careful when we do the when we actually simplify this expression. The common mistake is for students to think this is just 3x squared. No, it's not. It is 3x times 3x. So it's going to be 1 times 3x times another 3x. That is the first term. This is the first term right here. Alright, so 3 times 3 is 9, and x times x. This 3 times 3 is 9, and the x times x is x squared. And this is 2 to the power of 0, which is 1. 1 times 9x squared. So the very first term will be 9x squared. Alright, and the second term will be 2, this is this 2, times, this is 2 times 3x. 2 times 3 is 6, and then x, which is 6x, so it's 6x. And this one will be 4, the last term will be 4. This is 4 right here, that's 4. This one is 4. 4 times, now anything to the power of 0 is actually 1, so be careful about that. Anything to the power of 0 is 1. When I do, if I do x to the power of 0, I get 1. If I do p to the power of 0, I get 1. If I get 3x to the power of 0, I'll get 1. So basically, 1 times 4 will be 4, and that will be the last term over there. So now we have this expression down here will be the final answer to this division. Okay, here you have it on the screen. So you have all of those evaluated and written as the final answer here. That is the answer to example number 5. Now we're going to go to example number 6, which uses number instead of variables. Here it is. Example 6. See here now we don't have x or a. We have not pure numbers. So like this is like x to the power of something, and minus a to the power of something, and then we have to break this 16 up to look like x to the power of something minus a. Okay, so remember, this is the form that we are trying to match. X to the power of n minus a to the power of n over x minus a. So our job is to break this, to rewrite these numbers to look like that. Now, 625 and 81, there's something common about them. We know that when we square something, we'll get 625. If we square another thing, we'll get 81. So we know that 25 squared is 625. 81 squared, 9 squared. Let's take that back. 9 squared. 9 squared is 81. Okay, so now we're almost getting there. So we just recognize that squares appear this way. So this is going to be 25 squared. So this new expression, another column, will be 25 squared minus 9 squared. Now that helps us a lot because we can see this 16 down here can be written as 25 minus 9. How do I know that? I know that the form of the expression here, the form of this expression has to match the form of the expression down here. I already have a 25 square minus 9 square. So obviously, this has to be 25 down here matching this. This has to be 9 matching this. So now, and it works out. You see, 25 minus 9 is 16. So this is basically how you figure out the x to the power of n and a to the power of n if you are given just pure numbers. All right, so the next screen should show exactly what I have down here. This is the new expression now, where they they match the x minus a, s to the power of n, a to the power of n, and then a minus x minus a. So what is next for us is just to plug in into the general formula that we had at first in example 1. If you remember the general formula, we have to start off with a to the power of 0, and then we go x to the power of 2 minus 1. It's going to be just x to the power of 1. So because this is 2, it's going to be 1. So the next screen will show you, which is this. So you have 9 to the power of 0 times 25 to the power of 1 plus 9 to the power of 1. This is my a. It's going start from 0, a to the power of 0, a to the power of 1. 25 is my x, so x to the power of 1, and then x to the power of 0. We know we are done because this is x to the power of 0. X to the power of 0 tells us we are done. So the next step is to now evaluate. 9 to the power of 0 is 1. 25 to the power of 1 is 25. So 1 times 25 is 25. So it will be 1 times 25, which is 25, that is that, plus 9 to the power of 1 is 9, times, remember, anything to the power of 0 is 1, times 1. So 25 plus 9, that is our next answer. Now I got 25 plus 9 down here. And 25 plus 9 is 34. And basically, that brings us to the end of all the examples. Now, as always, the best thing to do in mathematics is to practice, 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 practice. So you need to go and apply all of these examples to practice all of those homework examples or homework problems and more. And hopefully these videos have helped a little bit.